Now, when we factor quadratics, these are quadratics, the first step in factoring all quadratics is to pull something out called the GCF. Do you see a number inside of all three of these? Okay, a number inside of all three of those, hopefully you notice that number would be -2. That is your GCF. Now, once I pull out the -2, now I have to find out what happens. What I mean by that is -2 times what gives you -2x squared. And hopefully you notice that would be just simply x squared. And then, next one, -2 times what gives you -14x. Hopefully you realize that would be a positive 7x. And then here, -2 times what will give you positive 60. That would be a -30. So, I'm not done factoring. I just pulled out the GCF. That's the first step. Not all problems have a GCF. Actually, most don't. But if it does, you got to pull it out. And then you got to factor this, what's left over. Now, a common way a lot of people these days are factoring, they do this big X. They call it the diamond method. And they put the 30, -30 on top, that's the last number, and the 7 on the bottom. Okay, they take this number put on top and that number put on bottom. And what you're looking for is two numbers that multiply to get the top and add to get the bottom. You're trying to think of what two numbers multiply to get this and add to get the bottom. So it's kind of like, let's think about some numbers that multiply to get 30 to start with. Oh, by the way, since that's a -30, aren't one of these going to be negative?
Yes.
Not both, one of them. So for 30, it's 3 and 1, 30 and 1. It's 10 and 3. It's 2 and 15. It's 6 and 5. There's a lot of options. Some of you figured it out already. Is it 3 and 10?
-3.
So we have 3 and 10, right? And which one's the negative?
3.
Hopefully you see that would be -3, because when you multiply those, you get -30. When you add them, you get 7. Okay? And then what's so cool about this, those are your factors, -3 and 10. So your answer, you keep the -2 out front, and your answer is going to be x minus 3 and x plus 10. That is factored form of this. Now, let's think of this as graphs. Do you guys remember standard form here? Can you tell my y-intercept is 60? Can you tell it's going down and your a value is -2? Look at this. Is your a value still -2? Am I now in intercept form?
Yes.
Do I know my zeros, 3 and -10? That's useful. And we're going to be doing this later and using factoring to find different forms. It's a conversion tool to find different formats. And that is important. Okay. This one, does it have a GCF?
No.
No. So what my little method, the method I'm going to show you for doing this one is kind of like a trick. It doesn't make sense kind of why it works, but it's kind of a slick, smooth way of doing it. So what we're going to start off with is an x, just like we did on the other one. But we're going to multiply these two numbers and put it on top. And then we're going to put the 5 on the bottom. Okay, you multiply the two sides, put on top, the 5 on the bottom. Now we got to think of 24. Okay, 24. I got 24 and 1, 12 and 2, 3 and 8, 4 and 6. So what is it?
-3 and 8.
Okay, people are saying 8 and 3?
Yeah.
So you have 8 and 3. And which one's the negative? -3. Now, you're not done though. These two numbers normally are okay, but since I multiplied the 6 in to get that -24, I have to divide those two numbers by 6. So what's going to happen now is I'm going to divide both these numbers by that 6. This 6 I brought in, I brought the 6 in. I now have to divide it off. Okay, this is a trick. This is a trick. This is a process to help you. And if you go with me with this, you'll like it with some practice. Now, can you reduce these fractions?
Yeah.
The fractions do reduce. Hopefully you notice this one is -1/2. And this one is at 4/3. So from there, I write my answer like this. Now, what I'm about to write is not your final answer, but you just take them and go like this. Isn't that what we did over here? You just take the two pieces and put them here. But the fractions aren't done. We are not done. This is not a proper notation. Our last step is to take your denominators and put them right in front. So your answer, your actual factored form would be 3x plus 4. And the 2 comes in front of there, so 2x minus 1. Again, this process does not make a lot of sense, but it works. Reminder, we multiply top and bottom. The 5 goes to the bottom. We do our normal diamond. We divide this front guy back off. You reduce. You then take both those numbers and the denominators jump out front. Is it possible that these could have reduced to like 5, 6, a whole number? Yeah, if it's a whole number, you don't take it and move it up because you can't. You'll get the hang of it. It's pretty nice. Students tend to like it. You'll get the hang of it. It just might take some time. So for this one, whenever you have squareds on the edges, both of these, there's some shortcuts that can help you. Now, first of all, you could think of number 3 as this. So you could think of it like that. That's a 0x. You don't need to write that, but you realize you could write it like that and see it as a trinomial. And then could you multiply 81 and negative 25 on top and 0 on the bottom? Who wants to go get 81 25s, 81 quarters, and then try to figure that out? It's a big mess. Terrible. So this shortcut's going to be nice. Now this shortcut only works if it's both squared with a minus between. Okay? It only works if it's both squared and a minus between. So it's a shortcut that only works for special cases. Here's what you're looking for. What squared gives you 81x squared, and what squared gives you 25? So the first one, what squared gives you 81x squared?
9.
9x. Because isn't 9x times 9x 81x squared? And what squared gives you 25? 5. So if that's true, if you have two squareds with a minus between, your answer's fairly quick and easy. These are very quick factoring techniques. It is simply 9x plus 5 times 9x minus 5. Done. It's that quick. One's a plus, one's a minus, take both. It only works, again, if this is a minus. They call this a difference of squares. If it is not a difference, it doesn't work. There is no sum of squares. It has to be a difference of squares. And they have to be squares. Now, is it possible that you might get a difference like this and they're not squares, but if you pull out a GCF, then they become squares?
Yes.
So sometimes you might pull a GCF out and then you have a difference of squares and you can do this. So difference of squares is a shortcut, and it's one of the easiest. This right here is called a perfect square trinomial. You don't need to really worry about that phrase. And this one also has a shortcut when the edges are squares. Because do you want to multiply 9 times 64, put negative 48 on the bottom? It would be horrendous. So whenever you see squares, you should start thinking, is there a shortcut? Let's check. So here's how the shortcut works. Same idea. What are your squared values we start with? I'm going to leave the negative 48 in the middle, negative 48x. So we're starting off with, what are the squareds? So what squared is this?
3.
What squared gives you 9x squared? That's 3x, and this is 8. So let's stick 3x there and 8 there. Now, before we go any farther, you have to do a check. There's a check that goes on. And what I do is I take both of these and I multiply them. And, this is kind of weird, you double it. You always double it. That doubling is like, why? Just because it works. Just trust me. If you multiply the two edges and double it, what do we get?
48.
Do you see how it matches the middle? If that matches the middle, we're good to go. If that does not match the middle, you stop and the shortcut does not work. Okay, it's a check. If you multiply these two and double it, if that matches the middle, we can go on with our shortcut. If it doesn't, the shortcut doesn't work, it probably won't factor either. It's very likely it won't factor. But the shortcut for sure won't work. And here's how the shortcut works. It's real simple. Basically, my shortcut answer is 3x minus 8 and 3x minus 8. They're both the same. I got a minus because what's that sign in the middle? See this, the negative 48? Because that's a negative 48, I put the minus in the middle. If that was a positive 48 there, there'd be a plus on both of these. Is that okay?
So
Whatever the middle sign is what the middle of these two are.
Would it just be squared?
So, which, you never see the answer like this. Here's how they finally write the answer. It's always written like this. So, you really want to technically, with practice, bypass this in red and jump straight to here. But what's nice about seeing this, don't these look very similar? Isn't this one 1 plus, 1 minus? And isn't this one both the same? So, this is what you want to get to, realizing it's always going to be the same squared. And again, whatever the middle, put that as a sign, and make sure this matches the middle. If it doesn't, the shortcut does not work, and it probably won't factor. Both of these are dealing with squareds. These two don't deal with squareds. These are your fallback, your normals. These are special cases that come up.